What if you could power our entire planet, forever, with fuel from a single glass of seawater? What if you could harness the literal power of a star and build one right here on Earth? This isn't science fiction. This is fusion energy, and it's closer than you think. In the next 4 minutes, you will understand exactly what it is, why it's so hard, and how we are finally starting to crack the code. First, let's get one thing straight. This is not fission. Fission is what our current nuclear power plants do. They split heavy atoms like uranium to release energy. It works, but it creates long-lasting radioactive waste. Fusion is the exact opposite. Fusion combines light atoms like hydrogen to create a heavier one, like helium. When they fuse, the new atom weighs less than the two original atoms combined. That missing mass is converted into a colossal amount of energy. Thank you, Einstein. This is the same process that powers our sun and every other star in the universe. The best part? The fuel for fusion is hydrogen. Specifically, two special versions, or isotopes, of hydrogen: deuterium and tritium. Deuterium is abundant and can be easily extracted from seawater. Tritium can be bred inside the fusion reactor itself. The fuel supply is virtually unlimited. So, if the fuel is everywhere and the energy is clean, why aren't we all using it? Because you are trying to build a star. And stars are extreme. Atomic nuclei are both positively charged. They despise each other. They repel with incredible force. To make them fuse, you have to overcome that force. You have to slam them together. And that requires 3 insane conditions. 1. Extreme temperature. We're talking over 150 million degrees Celsius. That is 10 times hotter than the core of the sun. 2. Sufficient density. You need to crowd enough fuel particles into one tiny space to make sure they actually find each other and collide. And 3. Confinement time. You have to hold that superheated, super-dense fuel together long enough for fusion to actually happen. At these temperatures, the fuel isn't a gas anymore. It becomes a 4th state of matter called plasma. This plasma is a swirling, chaotic soup of charged particles, and it will instantly vaporize anything it touches. So, how do you hold a 150 million degree star inside a box? You don't. You hold it with magnets. Method 1. The tokamak. This is the most popular design. It's a giant hollow donut wrapped in massive, superconducting magnets. The plasma is electric, so it's controlled by the magnetic fields. It's held in a perfect loop, floating in the center, touching nothing. The biggest one being built is ITER in France. It's a collaboration of 35 countries, a machine of mind-boggling scale. Method 2. The stellarator. This is the tokamak's wild cousin. Instead of a simple donut, a stellarator uses an incredibly complex, twisted shape to control the plasma. It looks like something from an alien world, and it may be even more stable. Method 3. Inertial confinement. This is a completely different approach. Forget magnets. Just use lasers. At the National Ignition Facility in California, they take a tiny pellet of fuel, smaller than a peppercorn, and blast it from every side with 192 of the world's most powerful lasers. This crushes the fuel pellet, creating the temperature and density needed for fusion, for just a fraction of a second. For 70 years, we've been trying to solve one problem: net energy gain. We've always had to put more energy in to heat the plasma than we got out from the fusion itself, until December 5th, 2022. For the first time in history, the National Ignition Facility did it. They achieved ignition. They fired 2 megajoules of laser energy at the target and got 3 megajoules of fusion energy out. We got more out than we put in. We proved it can be done. Now, the race is on, not just to get net energy, but to build a commercial power plant that can do it continuously and efficiently. This is the Holy Grail, an energy source with 0 carbon emissions, no risk of meltdown, no long-lived nuclear waste, and enough fuel to power humanity.